When we first talked about variables, one of the variable types that we talked about in Python was called a boolean. So if we had a variable b, we could set it equal to true, or we could set it equal to false. And those true-false variables would allow us to control flow in programming in certain types of ways that we're going to talk about in just a little bit. But how do we come to those true and false values without just setting them directly equal to these keywords? Well, we can do that with the use of some relational operators. So the relational operators are different ways to test if values are true or false based on how they relate to one another. So you already know from math, the less than symbol and the greater than symbol. Obviously 1 is less than 3, so that returns true. 1 is not greater than 3, that returns false. We also have a way to compare if they are equal. Notice we have a double equal sign here because we already know that the single equal sign is the assignment operator. So we don't want to use a single equal sign here because that's just going to try to assign the value 3 to 1, and nothing would ever make sense again if that were the case. So instead, a relational operator is asking, are these values related in this way? And Python is going to tell you true or false. So is 1 equal to 1? Yes. Is 1 equal to 2? False. There are several types of relational operators. There's equal, not equal, less than or equal, greater than, or equal. Most of these are probably pretty familiar from math class. This one here, the not equal, might be less familiar, but it works much as like you might expect. So we know that 1 equals 3 is going to return false, but 1 not equal 3, if 1 is not equal to 3, we should get a true. And if 1 is not equal to 1, we should get a false. So we can use the Boolean values from these relational operators to control flow in a program. So, for example, if we had a variable x and we wanted to do something based on the value of x. So, for example, if we wanted to say if x is a string that equals Monday, so let's say, x is the day of the week. Then we can say, I hate Mondays. And if it's a different string, then we can just say, okay, great. Now, let's assign a value to x. First, let's see if it's equal to Saturday. And you can see I've already made a mistake. This is good. I'm going to leave this in. So I've used the assignment operator here instead of the relational operator with the double equals. And now let's try it again. And we see that it's not equal, and that's fine. Whereas if this is equal to Monday, then we get I hate Mondays. Now, strings you can test with the equality symbols just like you can numbers, but sometimes it gets a little tricky in Python. So there might be better ways to test strings for equality or similarity or finding one string within a string. We'll look at that later. But we can certainly see numerical values pretty easily. So let's say if x is greater than or equal to 25, then you can rent a car. So let's give this variable a good name. So this is age now. Get someone else to rent your car. Okay. So we can see pretty clearly what's going to happen here. Age is 21. If age is greater than or equal to 25, we'll take the first path in the branch. If that fails to execute, we will go to the next line, and that will execute for any other case, and therefore we'll see what happens. Yay! Whereas if we put in 27 for the age here, you can rent a car. Okay? Now, we are not restricted to just one if and else statement. We can also use what's called an else if. But in Python, we write this as elif. And an elif is an additional condition. So we're not taking all other cases. It's a case specifically that you test only if the first if fails. So if you're greater than or equal to 25, you can rent a car. Else if age is greater than or equal to, I'm making up some rules here, I don't know if real car rental works this way. If it's greater than or equal to 18, print you can rent with the cosigner. And then finally, else, you'll get someone else to rent your car. So this is called chaining. If you have a sequence of conditions, usually separated with an else if command, and then finally the else takes all the remaining conditions. So let's think about how this works. If age is greater than or equal to 25, then we follow this first branch. So any age that is greater than or equal to 25 is already cut off. For anything less than 25, we're going to consider the remaining branches. Among those, if age is greater than or equal to 18, we're going to consider the middle branch. In fact, we're going to follow the middle branch. So for ages 18 to 24 inclusive, assuming we're only doing integers, which there's no restriction here that we're only doing integers, but let's just think of it that way. For age 18 to 24 inclusive, we'll follow the middle branch. And then for any remaining ages, the else will take up, and we'll print that. So let's see if this continues to work. For age 27, you can rent a car. Let's pick an age between 18 and 25, so let's just say 20. You can rent with the cosigner, and let's pick 16. Okay. So you might, in addition to having a sequence or a chain of conditions, you might also have nested conditions. So let's say, for example, we need to determine if you can rent a car. Let's say, let's do a better variable name that has insurance. So you either have or don't have car insurance. I'm making up all kind of car insurance laws right now, so don't listen to me. And so let's say that if you're over 25, you can just rent a car. If you are younger than 25, but 18 or older, then we have an additional condition. If you has insurance, in that case, you can rent with a cosigner. But else, print no, sorry. So if we consider these conditions now, the first conditions are just like we had before, which are the branches are selected by the age. But now the middle branch has an additional pair of branches, and those are controlled by the boolean variable has insurance. And you can see if has insurance is true, we're going to follow the we can follow the first branch that comes out of the middle. And if it's false, we'll follow the second one. So let's go back to age 27. We see you can rent a car. If we are 21 and we has insurance, you can rent with a cosigner. But if we are 21 and don't has insurance, then we cannot rent a car. And if we are 16, whether we has insurance or don't has insurance, it doesn't matter because the branch only occurs out of the middle condition. Now there are times when you have several branching points that you might want to select that would run into a bunch of elifs. So let's say you wanted to convert a grade to a letter. So if grade is greater than or equal to 90, letter equals A, and then we can have an elif. This needs to be grade. $80, you get a B. $70, you get a C. $60, you get a D. And otherwise, you get an F, right? There might be some grammatical issues here. You can fix that with more work, but there you go. And we could do a better job here. We could say grade equals input, enter a grade. Oops. So we can say you got a 76, yeah, and so forth, right? So sometimes you want to compare more than one thing at a time, sort of similar to what we did with the person trying to get a car. And you can do that with logical operators. So for example, if you have a variable x, and you want to see if x is greater than 3, and x is less than 8, you can do both of those at once. So you can say x is greater than 3 and x is less than 8. And in Python, you can just literally use the word and. You can also use the or. So let's say you wanted x is greater than 6 or x is less than 8. And so that will evaluate as true if either or both of these conditions is true. Whereas the and will only evaluate as true if both of these conditions is true. So x is greater than 3 is true, x is less than 8 is true. Since they're both true, this will evaluate as true. But if I change this to x is greater than 3 and x is greater than 8, the second condition is no longer true, so it'll evaluate as false. For the or, x is greater than 6 is not true, but x is less than 8 is true. Since one of those, at least one of those, is true, it will evaluate as true. If they're both true, still evaluates as true. But if they're both false, so if it's less than 2, if it's less than 2 and also greater than 10, this one evaluates as false, and this one also evaluates as false, and so the overall result is false. We can also use a not operator. So we know the values of x is 5, and so we know that x greater than 10 is false, but we could also just put a not out front. So x is greater than 10. If you want the not of that, it's true. It just reverses the truth of the statement. So it's pretty obvious that if something is true, we're going to follow this first branch. And if it's false, we're going to follow the second branch and print false, right? So if I just execute that, that's true. Fine. Now, Python has additional values for other variable types that are called either truthy or falsy. So falsy or truthy. Falsy things are different variable types where the content of the variable type is nothing or nothing-ish. So for ints and floats, 0 is falsy. Everything else is truthy. For strings, an empty string is falsy. Everything else is truthy. Those are going to be the ones that you encounter most often, but we also have instances of classes and related things. If you have a none for an instance, it is falsy, and we'll talk later what that means. I'll show you a short example, but we won't get too big into what that means. So, real quick here. So if x is equal to 0, we see that it's false. But if it's -1, we see that it's true. If it's 0.000, we see that it's false. But if we put a 1 there, suddenly it's true. Right? If x is equal to an empty string, it's false. But if we put a space in there, now it's true. And definitely if we put stuff in there, then it's definitely true. And the last one is a little harder to describe till we go in more depth. But let's import a turtle and just say turtle.turtle. And we've got a turtle. But if x is not pointing at anything, if it's pointing to an empty address space, that is the keyword none, and that's false. That's going to be a useful identifier, mostly later. So how can you use booleans? Booleans are mostly used for flow control, but you can also have methods that return boolean values. And one such way that you can do that, let's say we're going to enter a letter, and we're going to see if that letter is upper or lowercase. So what we'll need to do this is, if you look at the decimal value of a character, so for example, A, you can see that its ASCII value is 65. So if you convert 65 to a character, you get A. And if you do capital Z, it gives you a 90. If you do a little a, you have a 97. So there's a range between 90 and 97 where there's just other characters, right? But from 97 up to, what's 26 plus 97? 123? Nope. Yeah, 122 is the last one. All of those are lowercase. So, we can ask a function, is it uppercase? There's a reason I'm putting this weird syntax. Is it uppercase? So we can say if, actually we can do it easier than that, return ord x. So the values for the ord are between 65 and 90. So we could say less than or equal to 90 and ord x greater than or equal to 65. And this would be perfectly acceptable. Let's go ahead and do this, and I'll show you something else in a second. So, is it a letter? Well, I put the prompt wrong. And also never called it. So, let's say that we are going to put this in a better place. And then we're going to say, call, is it uppercase x? So if is it uppercase x, we can say print x was uppercase. Okay. Looks like I forgot to finish the name. Okay. But just like in math class, Python is very friendly about chunking together sequences of relational operators. So many languages would not like you to put two relational operators next to each other, but Python correctly interprets this as 3 is less than x and x is less than 5, because that's what that means, right? And so we can combine these two together as 65 less than equal to ord x less than equal to 90. Let's go ahead and put an else on there. Okay. We could do the same with lowercase, right? But the values are, what did we come up with? 97 to 122. Yay. We'll do another one. Okay. There are better things to do with this program than what I've done, but the point was to show you how to return a Boolean value. Notice that this didn't have to be evaluated on a separate line. So we could have said b is equal to this value and return b, but we could also, just like we did, return the evaluation of this expression immediately as it was calculated. Now, the last thing I want to do is just to mention Python has its own string evaluation Boolean methods. So we can already just answer, well, I won't kill everything here. We can just say, it just has a method for that. Oh, yeah, get rid of that. Right. So we never needed that. However, this method will work for several values where I don't think hours is going to work that well for more than one letter. Yeah. So if we wanted to fix hours to work for more than one letter, we would have to do something where we're taking only one character for the string, and that's something we'll learn to do pretty soon.